In this lesson, we're going to talk about kind of how the human ear is sort of designed to function and how that lets us hear things. So what's going on in the human ear is you've basically got a giant kind of cup shape. That's, this part of the ear, the outer part. And that's going to kind of trap air in it. So the vibrations that come in, this kind of channels them all to the hole that actually goes into your ear. So you have these vibrations in the air coming in, and then when they get to the hole, then they go into your ear. Then inside your ear, or inside the ear, there's this little tiny eardrum, and that's just basically a really thin membrane over an empty gap. And when the air vibrates, what happens is, if we zoom in on that eardrum, what happens is you'll have high pressure, like a bunch of air really packed together, low pressure, high pressure, low pressure. So instead of doing dots, I'm just doing lines. You can kind of get that idea. So you got high pressure, low pressure, high pressure, low pressure. Well, high pressure means this eardrum gets pushed inwards slightly. It gets compressed. Low pressure means that it gets pulled outwards. And so what that does is that means the eardrum here will perfectly replicate the vibrations in the air, or it'll vibrate at the same rate that the air is vibrating at, because it's exactly responding to these high and low pressures. So if there's a high frequency sound wave, meaning those air particles are vibrating back and forth really fast, these are really close together. If it's high frequency vibrating back and forth really fast, then that means the eardrum, in theory, will also vibrate back and forth really fast. If they're vibrating slowly, it will also vibrate slowly. As a result, through biological fanciness that even I'm not sure of all the exact details on, that gets converted into an electrical signal that travels through your auditory nerve into your brain, and then your brain understands that as sound. Now, we talked about how amplitude tells you how loud the sound is, and because that's received by the ear. If there's a big difference in pressure, that means the eardrum will move a lot more. And the more your eardrum moves, the more strong that signal going to your brain is, and by extension, your brain interprets it as a stronger or louder sound. This is also why high volume sound can damage your hearing, because your eardrum, flying back and forth, stretching back and forth by a huge distance, is going to wear it out, or potentially it can cause it to tear or rip or something like that. So that's the basic gist of how sound works, is the vibrations in the air get perfectly mirrored on your eardrum, which in turn creates an electric signal that it sends to your brain. Just like when we saw light hitting our eyes in the light unit, and that gets converted into electric signal that goes to your brain. This is actually in some ways simpler, because it's just one sensor, the eardrum, vibrating back and forth. Now, there's lots of cool things that end up happening that I'll probably talk to you in class about, how sound can kind of layer on itself and do complex things. But this is the basic idea of how kind of the human ear works.